Hi there. I made this next example in case you wanted to see me do another box and whisker plot. The shape of this graph is a little bit different, but the strategies are exactly the same. So below are 14 randomly selected GPAs of WHS Prob and Stats students. So there are approximately 69 of you taking probability and statistics right now. So I actually went through and randomly selected 14 of you, and these are the GPAs. Of course, it's anonymous. I didn't put any of your names with this. I certainly wouldn't do that. So I use GPA data because it is an example of data that will show the type of skewness that I wanted you to see here. So we could, of course, enter this into the calculator and do it on the calculator very quickly, although I could almost graph it just as fast by looking at the data since I've already put the data in order. There are 14 observations here, so I start by finding the median. The median would be between the 7th and 8th observation, and if you average those, you'll get 3.4. So that's the median. So these 7 observations then are the lower 50%. So here's the middle of the lower 50%. There's Q1. Here's the minimum. Here are the upper 7 observations. So here's the middle of them. Here's Q3. And here's the maximum. So I already have the 5-number summary without ever having typed in the data into the calculator. So here it is. The minimum is 2.1. Q1 is 2.8. The median is 3.4. Q3 is at 3.7. And then the maximum is at 4. So it doesn't take long then to plot this. So we should probably label the graph. So these are prob and stats GPAs. So to keep things simple here, I'm going to start with a 0, and I'm going to use a scale of 0.2. So 0.2, 0.4, 0.6, 0.8. Here's 1. 0.2, 0.4, 0.6, 0.8. Here's 2. 0.2, 0.4, 0.6, 0.8. There's 3, and so forth. And there's 4. So to create the box, I'll put a bar at 3.4 for the median. So here's 3.4. Q1 is at 2.8. So here's 2.2468. Here's 2.8. Q3 is at 3.7. So here's 3.2, 0.4, 0.6. 0.7 would be right halfway in between these. So there is my box. The nice thing about having a physical representation is now I can see the IQR. Remember, the IQR is the range of this middle 50% of the data. So each of these units represents 0.2. So the IQR is 0.2, 0.2, 0.2, 0.2, and then another 0.1. So that's 0.9 units long. So the minimum is at 2.1. So I'll draw my whisker. And the maximum is at 4. There we go. There's the box and whisker plot. The reason that I wanted to do this graph was because GPAs are an example of data that often, as people get closer to graduation, these tend to look skewed to the left. Our first example was skewed to the right. These are skewed to the left. So notice this graph is stretched to the left. This whisker and also this part of the box, they are longer than this whisker and this part of our box. So the graph stretches out to the left. That's why we could say that this graph is skewed left. So I went ahead and made the graph in pen because I know there aren't any outliers. And another thing about this graph, notice that the interquartile range, which is 9, and again, the way to calculate that, the IQR, if you didn't want to just count it from the graph, and you have to be careful there because you have to watch the scale, you could just take Q3 and subtract Q1. So 3.7 minus 2.8, there's the 0.9 again, the IQR. Notice the IQR is actually relatively large here. So understand, I can see physically that there aren't going to be any outliers. If I take that entire IQR, if I increase it by 50%, and then take that span and subtract it from below Q1, My lower boundary is going to be way below the 2.1. Same thing, if I take that IQR, if I increase it by 50% and then tack that on to Q3, I'm way off of the graph. I've got an upper boundary that way exceeds a GPA that people could possibly get. So I do want you to know how to do the calculation, but in this case, the reason there aren't any outliers is because there is already so much spread in the middle 50% of the data. Taking that and increasing it by 50% allows for so much variability that in fact you're not likely to get outliers. So the actual calculation, remember, for the lower cutoff would be Q1, take away 1.5 IQRs. So that value would be, let's see, what is Q1? It is 2.8 minus 1.5 times 0.9. So 2.8 minus 1.5 times 0.9, that is 1.45. So that is the lower boundary. That would be way, way over here. So the truth is we don't have anyone even close to being an outlier to the left. And then to the right, it's not possible. I'll calculate it anyway. So Q3 plus 1.5 IQRs. The value of Q3 is 3.7, and then I'll add 1.5 of the IQRs. So that comes out to be 5.05, and that's not a GPA that's really even possible. So we don't have any outliers in this graph, and we could have seen that very quickly by using the graphing calculator. So if I switch over to my calculator here, here is the box and whisker plot that I graphed for the previous example. Remember, stat, press enter. I've already entered the data into list 2. If you haven't entered the data yet in your calculator and you want to practice actually putting this on your calculator, pause the video now, enter the data. You can either enter clear list 1 and enter them into list 1, or you can put them into list 2 like I have. I just have them here to be prepared for convenience. Pause the video, put them in, and we'll keep going. Once you have the data then in the calculator, mine are in list 2. Again, we already know what the 5-number summary is, but anytime I'm doing a box and whisker plot, I think it's good to go ahead and run the one variable statistics. So stat, calculate, under one variable statistics, my data are in list 2. So if I had the command come up on the home screen, I would have to press second 2 next to it to get list 2 next to it. In this case, same thing. I have to specify that I want to calculate my one variable statistics for list 2. So here we go. If I scroll down, there's the 5-number summary that we had before. And what's important here to make a graph, what's important is to look at the minimum and the maximum. So the minimum is 2.1. So I want to go a little lower than 2.1, and I want to go a little higher than 4 in my window in order to see a plot of my box and whisker plot. So for the window, let's say for the minimum, I'll go to 1.9. And then for the maximum, I'll go to 4.1. Again, nothing else matters in terms of making the box and whisker plot, but recall, right now, if I press second y equals, notice I have my first plot turned on, but I'm currently plotting from list 1, and that's not where my data are. I need to switch that to list 2. That's where I've put my data. If you cleared your data and re-entered the GPA data into list 1, you don't need to do this part. I have to do this part because my data were in list 2. So I'm going to go into plot number 1. I'm going to highlight list 1. I'll press second 2 to change it to list 2. And now I should be good to go. We'll hit the graph button. There's the box and whisker plot. And again, we could trace it, no problem. There's the minimum at 2.1. There's Q1 at 2.8. There's the median at 3.4. Q3 at 3.7. And there's the maximum at 4. So you can get the 5-number summary by running the one variable statistics, or you can just plot it, and you can get the 5-number summary strictly by tracing it. And this is the option that should check for outliers, and I see no outliers graphed here. I know I'm good to go. Let me remind you then, make sure that when you're doing a box and whisker plot that you select the correct option. So again, for second y equals, if you go in here, this is the option that you want. This is the box and whisker plot option that will check for outliers. So again, if you go into that plot, you have to go down here to type, And the type you want, here's the histogram that we've used before. This is not the box and whisker plot option you want here. This one won't check for outliers. This is the one that you want to select. So you have to press the right arrow to get over to that option and press enter to highlight that option and select it. So it'll automatically check for outliers. Hope this extra example's been helpful.